Hello GATE aspirants, welcome to part 11 of GATE Nuclear and Particle Physics series. Question number 7. The total angular momentum Z of the ground state of 17O6 oxygen nucleus is. Now for this we have Z is equal to 8 and N is equal to 9. And the series is like this, 1s 1 half, 1p 3 by 2, 1p 1 by 2, then 1d 5 by 2 and so on. So 2, 4, 2, these are 8 plus 1. So last one is 5 by 2. So Z pi will be 5 by 2 and then this is D terminal, SPD, that means L is equal to 0, 1, 2. So L is equal to 2, that means pi is equal to minus 1 raised to L. So that is minus 1 raised to 2, which is 1. So this will be plus 1. So this will be the state, ground state. So for this we have Z value is 5 by 2. Option D is correct. Next question. Particle X is produced in the process. This is the process. Via strong interaction. If the quark content of K plus is up quark and this is S bar, US bar, the quark content of X is. S is stretched vertical. Now this is the reaction. Now let us consider charge. Now charge, this is charge plus 1, then plus 1, plus 1. That means this also has to be plus 1. Next, spin is equal to. This is spin 0 particle, spin half. This is 0 and this is spin half. Conservation of spin will be there. Then baryon number will also be conserved. So 0 plus 1, 0 plus 1. Next, isospin. Isospin is, for this it is 0. Then half. Then this is 1 and this is half. So I3 component, that will be plus 1, half, then half, plus 1. So this is also conserved. This also has to conserve. So that's why these are the values, possible values. And then strangeness number is 0, 0. And quark content of this is minus S bar. So S bar it is there. So this will be plus 1. That means here it has to be minus 1. So that means there should be S strange quark there. So option C is correct. Or without doing this, as you can see, K plus has quark content equal to US bar. That means the other particle has to have S, so as to conserve the number of strange particles. So from there also you can conclude that option C has to be correct one. Next question, number 14. If E bar and V bar are the electric and magnetic fields respectively, then E bar dot V bar is. Now these are parity and time reversal. So for parity, E bar transforms to E bar only. It remains the same. And for B bar, it transfers to minus of B bar. Similarly, time reversal, it changes the parity of electric field and it keeps the V bar same. So this is the case. Now under parity operation, V bar will change sign and under time reversal, E bar will change sign. So in both the cases, E bar dot V bar is going to change the sign. So option C is correct. Both will be odd under parity and under time reversal. Next question. A particle Y undergoes strong decay. Y is decaying like this. These are pi mesons. The isospin of Y is. Now isospin bar, these particles are 1 and 1. That means it has to be 2. So the answer is 2 because it is decay, strong decay. So for strong decay, strong interaction. So for strong interaction, isospin is conserved. So here answer is 2. So answer in the answer key was 2, 2, 2. Next question. According to the Fermi gas model of the nucleus, the nucleons move in the spherical volume of radius r is equal to r naught a raised to 1 by 3, where a is the mass number and r naught is the empirical constant with the dimension of length. The Fermi energy of the nucleus EF is proportional to. Now EF is equal to h cross square by twice m into we have 3 pi square n raised to 2 by 3. and this n is number density. So this is equal to h square by twice m 3 pi square n by v whole raised to 2 by 3. So this is equal to h squared by twice m, then we have 3 pi square n raised to 2 by 3 upon 1 by v. Now v is equal to volume, so volume can be written as 4 by 3 pi r cube, the whole thing raised to 2 by 3. So this is equal to h cut square by twice m, then we have 3 pi square n raised to 2 by 3, then 1 upon 4 by 3 pi. Now this r can be written as r naught into a raised to 1 by 3 raised to 2 by 3, and here dependence of r naught is asked. So we have in the denominator r naught and raised to this 2 by 3 thing. Now this will be cube of this, so this will be 3 and this will be 1 here. So we have this EF proportional to 1 upon r naught raised to 3, this whole thing raised to 2 by 3. That means EF is proportional to 1 upon r naught square. So option C is correct. Next question. In the center of mass frame, two protons, each having energy 7000 giga electron volt, collide to produce protons and antiprotons. The maximum number of antiprotons produced is. Now these are two protons and then they are converting into protons and number of antiprotons and protons. Now the available energy is 7000 into 2. So that is 14000 giga electron volt, out of which the proton will be having energy, single proton will be having energy 1 giga electron volt. So that will be one proton-proton pair. So we have to divide that. So 2 into 1 giga electron volt, that will give us, this will be minus 2, 14000 minus 2, that will be the energy of two protons, right? And we require energy of only this number of protons only, antiprotons only. So this will be 1400 minus 2, so that is 13,998 giga electron volt, and then we have to divide it by 2. So that will be number of antiprotons, and that comes out to be 6999. That will be the number, and answer to this question in the answer key was 6999 to 6999. So these were all the questions from GATE 2020 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.